What is sort aggregate and hash aggregate in Apache Spark? When we do group by in Apache Spark, then it's possible for it to implement it in one method which is called sort aggregate, or in another method which is called hash aggregate. Why do we have two methods to do the group by? Because each method has its advantages and disadvantages. The sort aggregate, as we'll see, is as fast as sort n log n, but n log n in big data is n times how many lines we have times log n. Okay, and the hash aggregate speed is just n. So sort aggregate has a disadvantage in speed because it's n log n, because as the name says, it's doing a sort. And the hash aggregate will not do a sort, it will just go over each line one time. Again, to give the context, in Apache Spark, we can do the group by either with an SQL statement with the group by clause, or we can do the group by with actual commands by doing a standard group by. Okay, so there is also a space consideration. When we do a sort with the sort aggregate in order to do the group by, then we can do it in place. Okay, so memory-wise, the sort aggregate is efficient, but speed-wise, the sort aggregate is inefficient in comparison to the hash aggregate. The hash aggregate is not that memory efficient because it's really dependent on the number of keys that we have. So let's go over additional explanation of what is this sort aggregate and what is this hash aggregate. But first, let's say how can we know if the underlying implementation is a sort aggregate or hash aggregate, and whether we can influence it before we dive deep into them. So we can know if the group by was a sort aggregate or hash aggregate by going to our dataset in Spark and typing dataset.explain, which just as in standard SQL will show the execution plan. And in this execution plan, if we have a group by, then we'll see either a sort aggregate or a hash aggregate. A sort aggregate, as its name says, we'll first do a sort of all the rows, and when we have, so now we have a sorting of all the rows by the group by clause, and because we did a sort of all the rows, which takes n log n of all the rows by the group by clause, then we would now be able to bulk rows which have the same key. So if all 2 to 12 have the same key because it's sorted, then we can squash them. So this is the sort aggregate. It will first do a sort, which is n log n, which is considered inefficient in comparison to the hash aggregate, and then it would squash the results. Okay, so now for the hash aggregate. The hash aggregate will take all the keys that are in the group by. If you did in SQL group by 1, 2, 3, which means go by 3 columns, then it would hash them, which means it would put them in a hash map without actually hashing them. It would just take the column 1, column 2, column 3 if they are in the hash, and put them as the key in a hash table. Okay, so we have now a hash table where the key are the group by columns, and the values are the rest of the columns, okay, which should be aggregated. We want to aggregate the values. Because we are doing a hash, because we are taking each of the group by columns and putting them inside the key of a hash table, then if we have colliding, if we go to row number 12 and row number 13 is the same columns of the group by, that Spark would update the aggregation in the value. So it needs an efficient way to update the aggregation value. How does it do it? Actually, it stores this hash table outside of the JVM memory. Outside of the JVM, it uses sun.misc.unsafe, which was excluded, removed from Java 9 and on. And this is the reason why Spark only works up until Java 8, because it needs this sun.misc.unsafe. In this sun.misc.unsafe, it has methods to read in Java and write to raw memory outside of the JVM in order for the updates of this hash table to be efficient. Now, if in the group by aggregation we happen to have a string, then it would not be able to use the hash aggregation, only the sort aggregate. So a way to optimize queries in Spark such that they would use the faster hash aggregate in comparison to the sort aggregate. If we see in the explain plan sort aggregate and we want it to be hash aggregate, we need to make sure that all the values are types which are not dynamic. Integer is a constant size, long is a constant size, byte is a constant size, double is a constant size. These are good for the values. Or if we have a string, we can move it to the keys. We can move it to the group by columns. If we move it to the group by columns, then it would simply put them as keys. And it would not need to update because we are updating the aggregations on the values. So this was a brief overview to sort aggregate, hash aggregate, which we see in Apache Spark in the implementation of group by. And also we have seen why Apache Spark is supported only until Java 8. And this sort aggregate and hash aggregate are also used in standard databases.